Welcome to The Explainer. All right, today we're tackling one of the most dramatic theories about the end of everything. I'm talking about the Big Rip.
So, when we talk about how the universe might end, there are really two main camps. You've got the heat death, which is this kind of slow, quiet, cold fade to black. And then you have the Big Rip, which is the complete opposite, a sudden, violent end to, well, everything, a cosmic scream instead of a whisper. So you've got these two very different ways it could all go down. And to really get your head around the sheer violence of the Big Rip, you kind of have to compare it to its much calmer cousin, the heat death. But you know what? We're not here to talk about the quiet ending today. We're going to dive into the scream. Okay, so where in the world did an idea this wild even come from? I mean, it sounds like science fiction, right? Well, the Big Rip theory didn't just pop into someone's head. It actually comes from a discovery that completely turned cosmology on its head. So picture this. It's 1998. You've got two separate teams of astronomers, both looking at these really distant, exploding stars, these supernovae. Now, everyone expected to find that the universe's expansion was slowing down, because of gravity pulling everything back together. But what they found was the complete opposite. It wasn't slowing down at all, it was speeding up. Something out there was hitting the gas pedal. And scientists needed a name for whatever this mysterious push was. They called it dark energy. And look, we have no idea what it is. We can't see it, we can't touch it, but we can absolutely see what it's doing. It's this invisible, relentless force that's just pushing everything in the universe apart, faster and faster. So how do you even measure something like that? Well, it all comes down to this one super important number. They call it the equation of state parameter, but we'll just call it W. And you can think of W as a sort of cosmic destiny dial. The exact number it lands on, that tells us everything about how dark energy works. And it basically decides the ultimate fate of our universe.
All right, and this is where it gets really interesting. This little number W gives us three possible futures. If W is greater than -1, the expansion actually slows down over time. If it's exactly -1, you get a steady, constant expansion forever. And that, by the way, is what most scientists think is happening right now. But what if W is less than -1? Then dark energy becomes something else entirely, something they call phantom energy. And this stuff is different. Its push doesn't stay the same. It gets stronger and stronger over time. That's the recipe for a Big Rip.
So let's just go there for a minute. Let's run the thought experiment. What if we are in that last scenario? What does a universe run by this phantom energy actually look like? Well, if phantom energy is the real deal, then the universe isn't just expanding. It's hurtling towards a very specific and, frankly, terrifying end. And the crazy thing is, scientists can actually map out a timeline for it, a step-by-step countdown to the end of, well, everything. So how much time are we talking about here? According to some of the models, the clock is already ticking. From right now, this whole catastrophic chain of events could unfold over the next 22 billion years or so. And the destruction wouldn't be random. It would be incredibly systematic, almost like it's working its way down a checklist. First, it would start with the biggest things. Clusters of galaxies would get pulled apart. Then, it would come for the individual galaxies themselves. Gravity would just lose its grip, and our own Milky Way would basically dissolve. After that, it's our solar system's turn. Planets, including Earth, would be flung out into the darkness. But it doesn't stop there. The phantom energy would then rip apart the stars and planets themselves. And then, in the final, unbelievable moments, it would overcome the forces that hold atoms together, the very building blocks of matter, torn to pieces. And this is the part that's so hard to wrap your head around. The Big Rip isn't just about blowing up stars and planets. It's the end of matter. Period. The expansion would become so powerful, so violent, that the very fabric of space-time itself would just rip apart. The end isn't a slow fade into darkness, it's nothing, a complete and total void. Okay, wow, that was a lot. A pretty intense trip into cosmic doom and gloom. So let's take a breath and pull back a bit. It's a terrifying theory, for sure. But what does the actual evidence tell us? Is this really where we're headed? So, bottom line, is this a done deal? Is this cosmic doomsday scenario certain? Should we start worrying about our atoms getting ripped to shreds? And you can breathe a sigh of relief. The answer, thankfully, seems to be no.
Based on all the best data we have right now, the Big Rip is not our most likely future. The scientific consensus is actually pointing somewhere else entirely.
And here's why. Our best measurements, I'm talking about huge projects like the Dark Energy Spectroscopic Instrument or DESI, they're all showing that the value of W is looking like it's almost exactly -1. And remember what that means? It points to that middle scenario, the cosmological constant model, a steady, forever expansion, the quiet fate of a heat death, not the violent scream of the Big Rip. And look, this isn't just a guess. This is an active, ongoing investigation. Scientists are constantly rechecking their work, refining the measurements. They're watching how galaxies move. They're studying the faint afterglow of the Big Bang, and they're using incredible tools like the Euclid Space Telescope to map out the universe, all just to nail down that exact value of W. But here's the thing. Even if the Big Rip probably isn't going to happen, just thinking about it, it forces you to ask some pretty big questions, right? Thinking about any ultimate end to the universe, whether it's a violent rip or a cold freeze, really makes you think about what it all means.
I mean, think about it. Does it matter how the story ends? Does knowing the universe could end in a violent bang versus a long, slow whimper? Does that change how we feel about the here and now? Does the final page of the book change the meaning of all the chapters that came before it? And it makes you think about our priorities, as a species. If you knew for sure the end was coming, what would you do? Would you focus all your energy on building a lifeboat, trying to escape to some other reality? Or would you focus on preserving everything we have right here? Our art, our knowledge, our culture, and making it last for as long as it possibly could? Which really leaves us with one last big thought to chew on. If everything, you, me, everything we've ever built, the planet itself, if it's all just going to be ripped apart one day, what actually endures? What kind of legacy could possibly survive when the atoms themselves don't?